quick review of the stuff from the previous video. So when you're looking for the range and the domain of a parabola, where they give you the vertex. So the range and the domain for a parabola where they give you a vertex, what you need to look at is the domain of a parabola is always all reals, and the range is, if this is your vertex, if your vertex is 1, -2, your range is going to be either y is greater than or equal to -2 or y is less than or equal to -2, and that depends on if it opens up or down. So if you have a parabola that opens up, then your range will be y is greater than or equal to whatever the y coordinate of this vertex is. Let's say that's 0, -1. y is greater than or equal to -1. And if it opens down, let's say this is the point 36, it is y is less than or equal to 6. And that's if you are told to write it in inequality form. So inequalities. So here's inequalities right there. If you are given the parabola as a function, such as y equals -2x squared plus x minus 3, and you are told to find the range, and let's say it's in interval notation, you find the vertex minus b over 2a. Let's make this plus 4. So minus 4 over 2 times -2 gives me minus 4 over -4, which is 1. That's the x coordinate of the vertex. The y coordinate of the vertex is ax squared plus bx plus c, where this value that you just found was x. A is -2 from right here. -2 times 1 squared plus b is 4 from right here times 1 plus c is -3. So this is -2 times 1 is -2 plus 4 minus 3 is -1. So the y coordinate of our vertex is -1. This parabola is opening down. When it opens down, it's -infinity to that y coordinate with the square bracket. If it opened up, then you would have your square bracket, and you would have the y vertex, comma, infinity. All right. Types of graphs. So you're given f of x equals 3, f of x equals minus x squared, f of x equals 2x plus 4, f of x equals 0, f of x equals -1/2 x plus 3, f of x equals x squared plus 2x. Okay. Just a number, no x at all, horizontal line. If it has an x squared at all, it's a parabola. If it's negative, opens down. If it has an x but not an x squared, it's a line. And you look at the coefficient of the x. If that's positive, then it has a positive slope. 0 is just a number. There's no x in there at all. That's a horizontal line. This one has an x but not an x squared, and the x is negative. So that's a line with a negative slope. This one has an x squared, that's positive, so it's a parabola opening up. Here's a little chart for you to remember. No x at all, x but no x squared, and an x squared. Coefficient of x or x squared positive, and coefficient of x or x squared negative. So if there's no x at all, horizontal line. There's no x squared, but there is an x, and that x has a positive coefficient like 6x, 1/2 x. That's a line with positive slope. If our x has a negative coefficient like negative x or negative 1/2 x, that's a line with a negative slope. Doesn't matter if it has a number with it as well. It might, so I could have +6 or -2, doesn't matter. X squared. If the x squared has a positive coefficient like x squared or 3x squared, then that's a parabola opening up. Doesn't matter if it has an x or a number, and the x or the number could be plus or minus, but as long as the x squared is positive, it's a parabola opening up. If the x squared is negative, then it's a parabola opening down. All right, so for these parabolas, when you see one of these opening up is positive, positive coefficient, negative coefficient. Coefficient closest to 0 is the widest. Greatest value opens up and is narrowest. Least value opens down and is narrowest. Alright, so on to the new ones. Use the graph of the parabola to fill in the table. Does the parabola open upward or downward? Well, that's pretty obvious. That one's downward. The coordinates of the vertex, so that's right here. Do pay attention to how it's numbered. So this is 1, 2, 3. The x coordinate is 3. The y coordinate is 0. So the coordinates of the vertex are 3, 0. Find the equation of the axis of symmetry. It's always going to be x equals the x coordinate of the vertex. X equals 3. Find the intercepts. The intercepts are where it crosses the axis. So x-intercept. So x-intercept, we look at the x-axis and we see where it crosses. It will have 0, 1, or 2 x-intercepts. This one has one x-intercept. It crosses the x-axis at 3. So the x-intercept is 3. The y-intercept is where it crosses the y-axis. So here's the y-axis. And it looks like it crosses, to me it looks like it crosses at -9. You could conceivably have, for x-intercepts, you could possibly have none, and you could have 2. So for example, one that would have none would look like this. So this would have x-intercept none, y-intercept 1, 2, 3, 4, 5. And you could conceivably have one that looks like this. Probably they wouldn't give you one without a y-intercept. They all have y-intercepts that just might not be shown. So this one has a y-intercept of 2 and x-intercepts of -1, 3, because it's got one here at -1, and then another one here at 3, -1, 1, 2, 3. Find the vertex, find the y-intercept, find the x-intercepts if they exist. Okay, vertex. So A is 4, B is -6, C is 4. The x-intercept of the x-coordinate of the vertex is x equals -b over 2a, or x equals 6 over 2 times 4, which is 6 over 8, which is 3/4, which is unfortunate. But I believe that is correct. -b over 2a, yeah. Okay, and so then the y-coordinate is 4 times 3/4 squared minus 6 times 3/4 plus 4, which is 4. If it doesn't say, if it says you have to give it as a fraction, then you'll want to make sure that you use these as fractions. If it doesn't, you can use it as a decimal in your calculator. So that's 0.75 squared minus 6 times 0.75 plus 4. Remember, if it's negative, if you raise it to a power, that you put it in parentheses. And that gets me 1.75, which is the same as 7/4. And so the vertex is 3/4, 7/4. Now the y-intercept is when you make x equal to 0. It turns out it's also always c. So if you have it in ax squared plus bx plus c form, the y-intercept is c. so it's 4. But also you get the y-intercept by setting x equal to 0. So if you have y equals 4x squared minus 6x plus 4, to find the y-intercept, you let x equal 0, y equals 4 times 0 squared minus 6 times 0 plus 4. That's 4 times 0 squared is 0. 6 times 0 is 0. 0 minus 0 plus 4 is 4. So y equals 4 is the y-intercept. The x-intercept is harder. It says the x-intercepts if they exist. So for the x-intercepts, you set y equal to 0. So I have 0 equals 4x squared minus 6x plus 4. So I want to solve this. I can use factoring, I can use a quadratic formula, I can use whatever works. But the first thing I want to do if I see it is if there is a common factor, take it out. It'll make your life easier. So I'll take out a 2, and then I have 2x squared minus 3x plus 2. All I did was divide everything in here by 2. And then if you want to, because this is an equation, you can divide both sides by 2 and make it go away. If it just says factor, you have to leave it in. But since it's an equation, you can make it go away by dividing both sides by 2. Now you can use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's minus 3 is 3, plus or minus the square root. Remember, if it's negative, you got to put it in parentheses to square it. B squared minus 4 times a times c all over 2 times 2. And I can see here I'm not going to have any x-intercepts, and you'll see why in a minute. 3 plus or minus 9 minus 4 times 2 is 8 times 2 is 16. 9 minus 16 over 4, that's negative. Now, you can have imaginary roots, but you cannot have imaginary intercepts. So when this turns out to be imaginary, to have an imaginary part, then you have no intercepts. So none. Use this information to graph the function. What you would do is you would take I don't know how the parabola grapher works, but it has a y-intercept of 4, so you would put that in there. It definitely opens up. It has an x-intercept of 0.75 and 1.75, so I don't know if it lets you go by quarters, but that's where that would go. You can also always just find another point on the graph. And so since this vertex was kind of hard to place, well, you really need to place the vertex. I don't know if it allows you to type the vertex in or not. Make sure I did that vertex right. Ignore me for a moment. Don't pay any attention to this. Yeah, that's right. Okay. So yeah. So you graph your vertex, you graph your y-intercept, and then you can just pay attention, and you'll see how it does not have any x-intercepts. Well, this is a good problem. I like this one. Graph the parabola and the axis of symmetry. Use a dashed line to indicate the axis of symmetry. Label the coordinates of the vertex and write the equation of the axis of symmetry. Use the graph to write the domain and range in interval notation. Okay, so this is written in vertex form. So x minus 5 squared plus 1. That's vertex form. That means our vertex is the opposite of this number. That's minus 5, so the vertex will be positive 5. And this number, you don't make it opposite. So it's 5, 1. So 1, 2, 3, 4, 5, and 1 is the vertex. The axis of symmetry always goes through the vertex. The axis of symmetry is x equals 5. I will find the y-intercept. The y-intercept is the easiest one to find. To find the y-intercept, you make x equal to 0. Well, that would give me 26, so that's pretty big, so that won't help me much. I'm going to plug in x equals 6. I'm just going to plug in x equals 6. Why am I doing that? Because I see if I plug in x equals 6, I would get 6 minus 5 squared plus 1, which is 1 squared plus 1, which is 2. That tells me I also have the point 6, 2 on my parabola. So here is my parabola. I know it opens up because there's no minus sign in front of there. Also, if there's no number in front of the x squared term, you know it's going to go from the vertex and up 1 and over 1, and up 1 and over 1. That number in front of the x squared term tells you how much you go up and over. If I had 2x squared was the term from my parabola, from my vertex, wherever it was, I would go up 2 and over 1, and up 2 and over 1. Domain and range. So domain in interval notation is minus infinity to infinity. And the range, it's opening up, so I have a square bracket. The y-coordinate of the vertex is 1, and then it goes to infinity. Okay, so this one, my vertex, again, is 5, 1. Is this the same one? This is the same one. This is a different one. Okay, so this one, notice it's opening down, so that's going to change things a little bit when it goes to draw it. But my vertex is 5, negative 3. So I'll go to 1, 2, 3, 4, 5, down 1, 2, 3, 5, negative 3. And it's negative, so it opens down. This number in front of the parentheses, that's a negative, that's understood to be a negative 1. That tells me I go down 1 and over 1, down 1 and over 1. And that would be my parabola. Axis of symmetry always goes through the x-coordinate of the vertex, so the axis of symmetry is x equals 5. Domain is negative infinity to infinity. And the range, since it opens down, it means it starts at negative infinity and it goes to the y-coordinate of the vertex and close brackets. Coordinates of the vertex, and determine if the vertex is a maximum or minimum point, then write the maximum or minimum value. So A is negative 4, B is 0, C is 0. Minus B over 2A is 0 over 2 times negative 4. 0 over negative 8 is 0. 0 divided by anything is 0. So the x-coordinate of the vertex is 0. And then ax squared plus bx plus c. So that's Negative 4 times 0 plus 0 times 0 plus 0 is 0. So the coordinates of the vertex are 0, 0. Now, it's negative, so it opens down. And when it opens down, vertex is maximum. When it opens up, vertex is minimum. And the max or min value, anytime you see the word value, that's a y-coordinate. In this case, they turn out both to be 0, but the maximum or minimum value is the y-coordinate. So the vertex is 0, 0. That is a maximum because it opens down. And the maximum value is 0. If I had 4x squared plus 2x plus 3, my vertex would be minus 2 times 2 over 4. The minus 1 would be my x value. 4 times minus 1 squared plus 2 times minus 1 plus 3 would be 4 times 1 minus 2 plus 3. 4 over minus 2 is 2 plus 3 is 5. So my vertex would be minus 1, 5. This one opens up, so that would be a min value. And the min value would be 5. Find the x-intercepts and the coordinates of the vertex for the parabola x squared plus 6x plus 9. So x squared plus 6x plus 9. Okay, so vertex minus b over 2a minus 6 over 3, minus 6 over 2 gives me negative 3, and then I'll plug that in. Negative 3 squared plus 6 times negative 3 plus 9. 9 minus 18 plus 9 is 0. So my vertex is minus 3, 0. That's my vertex. X-intercepts. To get the x-intercepts, you take your parabola, x squared minus 6x plus 9, and set it equal to 0. Easiest to factor if you can. This one is not bad to factor. You think of two things that multiply together to give the last number, multiply together to give that one, and add together to give that one. So two things that multiply together to give positive 9 and add together to give negative 6, negative 3 and negative 3. You set those equal to 0. X minus 3 equals 0. Add 3 to both sides. X equals 3. So we get the same thing on both of these, so there's just one intercept. X equals 3. You can use the quadratic formula. And let me think how to help you remember when you're factoring. So if I've got x squared minus 2x minus 35, they multiply to give this one, and they add to give this one. So when you're trying to remember, so you have x squared minus 2x minus 35. And you say to yourself, I am going to remember how to do this. I am going to remember how to do this. I am going to remember how to do this. Add, multiply. So I have to multiply to give negative 35, add to give negative 2, so that's negative 7 plus 5. So if I had x squared plus 4x minus 32, am going to remember how to do this. Add to give 4, multiply to give negative 32, x plus 8, x minus 4. And then if you're trying to find intercepts, you set these equal to 0, x plus 8 equals 0, x minus 4 equals 0, minus 8, x equals negative 8, x equals 4. Does the function have a maximum or minimum value? So it opens up, that means it has a minimum value. Where does the maximum or minimum value occur? Where is asking x. What is the value is asking y. Where is x? What is the value is y. Where is x? Well, x marks the spot. That's where it is. Where is x? X marks the spot. Okay, so let's find the vertex, minus b over 2a. That's negative 1. That's the where. The what, we plug this in to get the y value. Y equals negative 1 squared plus 2 times negative 1 plus 2. 1 minus 2 plus 2, that's 1. Where, just remember where is where the x is, because x marks the spot. What is y? What is y? Y is what? Okay. Moving on. A supply company, I was reading manufactures nectarines. Okay. A supply company manufactures copy machines, does not manufacture nectarines. Supply company manufactures copy machines. The unit cost in dollars to make each copy machine depends on the number of machines made. If X machines is made, the unit cost is given by the function. So they give you the cost function. So they give this to you. You don't need to worry about where it comes from. It's given. 0.4x squared minus 120x plus 24,432. How many machines must be made in order to minimize the unit cost? Okay, so it is asking how many must be made to minimize the unit cost. It could be asking, remember in the problem before we had the where was the x and the what was the y? If it was asking what is the minimum cost, we'd look for the y. But it's not. It's saying how many machines must be made to minimize the unit cost. Whenever it's asking how many, that's going to be the x. How many is the x? So minus b, so minus negative 120 over 2a, 2 times 0.4. So that's 120 over 0.8, which is 150. 150. So whenever this thing here is saying number, they're asking for the x. If it's what the function is doing, like if it asks for the cost, that would be the y. Oh, another good question. A set of fireworks mortar shells is launched from the staging platform at 120 feet per second from an initial height of 8 feet above the ground. The height of the fireworks can be modeled by. Okay, so they give you the function. You don't have to worry about where it comes from. H of t equals minus 17t squared plus 120t plus 8, where t is the time in seconds after the launch. For how many seconds after the launch would the fuses need to be set so the mortar shells would in fact explode at the maximum height? Okay, so notice they're not asking for the maximum height. They're asking for how many. They're asking for the x, or in this case, the t, because there isn't an x, so it's a t. So they're asking for the t. So minus b over 2a minus 120 over 2 times negative 17 minus 120 over negative 34 and I get 3.52941. It says round to 3 decimal places, so 3.529. If it wanted to know what is the maximum height, it's asking what is it? What is the maximum height? I'd plug this in for t. It says this is part 1 of 2, so I'm wondering if part 2 was to actually find the maximum height, and if it was, you'd have to plug this in. So you would take, on the calculator, negative 17 times 3.529 squared plus 120 times 3.529 plus 8. And I get 219.765. A baseball player throws a ball, and the height of the ball can be approximated by that, where x is the horizontal position of the ball measured in feet from the origin. For what value of x will the ball reach its highest point? Round to the nearest foot. Okay, so it's saying for what value of x? You know it's the x. It's asking for the x. So minus b minus 0.527 over 2 times negative 0.017. And you need to be careful when you do this on the calculator that if you're dividing this 2 times this, make sure you put that in parentheses if you do it all on one line, because if you don't, you get the wrong answer like I just did. $15.5 says round to the nearest foot. Exactly 15.5. Yeah, 15.5. I guess I'd round that up to 16. So that's the value of x. And then the maximum height, you would plug that in for x. So the ball will reach its maximum height at x equals 6. And then the maximum height would be negative 0.017 times. And now here, don't round. Plug in the original value, 15.5 squared plus 0.527 times 15.5 plus 5. And I get 9.08425, and it says to round your answer to the nearest tenth of a foot, so that'd be 9.1. Car mileage depends in part on the speed of the car. The gas mileage of a luxury car is given by blah, where 25, x between 25 and 70 represents. Okay, at what speed will the car get the maximum gas mileage? Okay, so we're going to start this the same way. It's saying at what speed, that's going to be the x. What is the maximum gas mileage? That's going to be the y. The at what or the where or the when, that's always going to be the x. The what is always going to be the y. So minus 1.32 over 2 times negative 0.012. Again, be careful that you use parentheses. I get 55. And then I just checked to make sure that was in my range, and it is. Don't think they give you one where it's not. And then the maximum gas mileage, you plug that in. Minus 0.01255 squared plus 1.32 times 55 minus 7. I get 29.3, round to the nearest whole unit, so that would be 29 miles per gallon. Okay, now, you know me, I likely made lots of mistakes in those calculations because I can't do calculations, but I hope that helps, and let me know if you have any questions.